So this question is find current I in the circuit using Tellegens theorem. So first off, for Tellegens theorem, we know that the power absorbed is equal to the power supplied. And we know that power is equal to plus or minus, depending on if the power is absorbed or supplied, the current multiplied by the voltage. So inside of the circuit, the current goes around like that. And because this is a single loop circuit, the current is the same throughout the circuit. So we're going to start at this dependent source. So why is this source dependent? Because the voltage depends on VA. So that's why it's dependent. So we're going to set up our equations now for power. So the power, I'm going to call it I for independent. Just don't get it confused with current. And that's negative. The current is I. And the voltage is 4.5 VA. Next, we're going to move on to the 25 volt source. So the power of 24 volt source is equal to negative. The current is I and the voltage is 24. Negative 24I is that power. The power across R1 is equal to positive. The current we know is I. The volt we don't know. We know it's VA though. Next, we're going to solve the power through R2, which is equal to plus I. We don't know the voltage, and we don't know the current. The only thing that we do know though about this resistor, about this voltage source, is that we know the resistance. But if you do know, and if you remember Ohm's law, is equal to V equals I R. Now, I'm going to highlight what we know about this voltage source. We know R, and we know I. And what we don't know about the power equation is the V. So we're going to substitute this inside that equation. So instead of P equals IR, P is going to be equal to I current times resistance. So that's current squared times resistance R. So if we go back to that, the power of the resistor 2, it's going to be positive. We don't know I, but we do know R, which is 2. Now if we go back to resistor 1, which I'm going to highlight, we also know the resistance. So I'm going to rewrite this using the P equals current squared times resistance. So R squared multiply resistance, which is 4. And this turns into R squared times 2. Now that we know all of the power equations, we're gonna make an equation. I'm gonna do it in blue. So negative I 4.5 VA minus 24 I plus I squared times 4 plus I squared times 2 equals 0. So how many unknowns do we have? We have 2. We have VA and we have the current I. How do you solve this? The answer is you can't. So we need something to substitute for either voltage A or the current. So in order to solve current, we need, looking at Ohm's law, we need voltage and resistance, but we don't know voltage because we don't know VA. But if we use Ohm's law to replace VA, and I is the other unknown that we don't know, and then we know that the resistance, if we go back to our circuit, the resistance where VA is, the resistance is 4. So now we can put that into our equation. So let me rewrite this equation in red using what we know now. Minus 24I, which is current, plus 4I squared plus 2I squared equals 0. Now we're going to multiply that out, and we're going to combine some of the like terms. Give myself some room. I'm going to write it in black. So 4.5 times 4 is 18. Negative 18. I times I is I squared. Minus 24I. And then these two are plus 6I squared equals 0. Now we can combine these. We can combine both of the terms with the I squared. So that gives us negative I squared. Negative 12I squared minus 24I is equal to 0. And from here, we just need to do a little algebra. So now we have the circuits out the way, we just need to know our algebra, which can be a little challenging at times, I have to admit. There I go. I almost factored out an I squared, but can't do that. So it leaves us with I plus 2 equals 0. Alright, and then we divide by that. Divide by that. And then we're just left with I plus 2 equals 0. Grand finale. That's a very ugly I for the grand finale. I equals negative 2 amps. So that's how we solve this equation. Most of it started off with knowing some circuits, but then it ended with knowing our algebra and using substitution,